Hi friends, this video we are going to solve this linear programming problem using Big M method. So it is a extension of Simplex method, but Simplex method we always require the less than or equal to symbol. But whenever our constraint has greater than or equal to symbol, we cannot apply the Simplex method. That is why we are going to use the Big M method. What is the Big M method says? The same idea only from the Simplex method, but initially we have to change to some fusing. So first we write our constraint as the equation form. So 2 times x1 plus x2 plus s1 as a slack variable, we get it as a 16. Second equation is greater than or equal to symbol. So x1 plus 3 times x2 minus s2. So here only we have to add the artificial variable. So we call as namely r1 equal to 20. Here already equal symbol will be there, but we require to the artificial starting point solution. That is why we require one more variable x1 plus x2 plus r2 equal to 10. So our objective function is, I have to write it as minimization of z equal to 2 times x1 plus 3 times x2 plus m times r1 plus m times r2. This way we have to write it. Now the r1 r2 value we get it from the equation 2 and 3. So from r1 equal to 20 minus x1 minus 3 times x2 plus s2, r2 from equal to 10 minus x1 minus x2. So you apply here. So our objective function is minimization of z equal to 2 times x1 plus 3 times x2 plus m times r1 value is 20 minus x1 minus 3 times x2 plus s2 plus m times r2 value is 10 minus x1 minus x2. Now we are grouping the x1 coefficient as the minimization of z equal to, so m times x1, correct? So m, here one m will be there, so minus 2m plus 2 times x1 plus x2 coefficients are 3 minus 4 times m x2. Then finally that s2 coefficients are plus m times s2, then remaining terms are plus 30 times m. This is our equation. Now you can represent, now this is a minimization problem. I want to use the simplex method. I want to use the maximize problem, is more convenient. So I can write this convert as the maximize of minus z plus 2 minus 2m times x1 minus plus 4 minus 4m, sorry here one minus, sorry here plus, so I want to change this side only, so 4m 3 minus 4m times x2 minus m times s2 equal to 30 times m. I want to write in the term of maximize problem. So minimize problem, I simply multiply the minus sign. So minus z. This is, if you take the equation left hand sides become 2 minus 2m, minus time will come. So I will again multiply the minus, it become plus. So this way only will get it, you will get it as this one. Now I substitute m equal to 100. So bigger method, this is the key idea. You can proceed with the M.Sc treated as a constant, you can proceed, but I can choose m equal to 100. So it is fine to use it. So our maximize function is maximize of, so our equation form minus z minus 198 x1 minus 397 x2 minus 100 times s2, so minus, so here plus will come, so this side is minus, so plus only will come, plus 100 times s2 equal to 3000. So here minus 3000 will come because I multiply with the minus sign on both sides, so minus 3000. Now I want to represent, what is my constraint? Constraints are 2 times x1 plus x2 plus s1 equal to 16, x1 plus 3 times x2 minus s2 plus r1 equal to 20, x1 plus x2 plus r2 equal to 10. So I want to fill it. So minus z coefficient is 1. This is from the this is the 0th row. It is from the always from the constraint. We already know the what is simplex, the same idea hereafter. So x1 coefficients are minus 198, x2 coefficients are minus times 397, s2 coefficients are 100, s1 coefficients are 0, r1 coefficients are 0, r2 coefficients are 0. My right hand side is 3000. Now s1 coefficient, this is from the our first equation, so here always 0. Now s1 first equation coefficient equation here you will get it as 2 1 0 1 0 0. Here you will get 1 3 minus 1 0 1 0. My right hand side is 16 20. Third equation is 1 1 0 0 0 1. Here you will get it as a 10. This is the initial table for the same simplex method. Okay. Now I want to proceed. So where I want to increase the z value will increase the maximum number of negative numbers. Correct. So this guy is the x2 is the this guy. Correct. This is the maximum negative number. So x2 is the new basic variable. So I want to remove from the s1 r1 r2. So I want to divide the solution vector divided by this column. Correct. So 1 divided by 16 divided by 1 is ratio is 16 here. You will get 20 by 3. Here you will get it as 10 divided by 1. So clearly what is the minimum ratio is 20 divided by 3. So R1 as the leaving variable. R1 is the leaving variable. X2 is the new entering variable. So I want to, what is the pivot position? Pivot position is, this is my pivot position. So I want to make it, this guy is 1. So I want to write R2 is, so this is not this R2, this is row 2. So okay, we can write the row 2 divided by 3. So R1 is become X1. So you take S1 here, S1 here, Here instead of R1 we get it as X2 is the new basic variable. Here divided by 3. So 0 divided by 3 is 0. 1 divided by 3 is 1 by 3. Here you will get it as 1 minus 1 by 3. 0, 1 by 3, 0, 20 divided by 3. Now, I want to make this the pivot position, means here also 0, the upper also 0 and lower of the column everything must be 0. So, I want to say take R, first I want to take 0th row equal to, so this guy means I want to row 0 plus 397 row 2. This is the way I have to add it. Now what will happen? So these guys become 198. So you will get it as, here you will get it as 1. Here you will get this minus 197 divided by 3. Here you will get 0 because that way only we will form. S2 is minus 97 divided by 3. 0. 397 divided by 3. R2 here is 0. Here you will get minus 1060 divided by 3. Similarly, the first row also I want to make it 0. So first row is what will take? R1 is, that is row 1. Row 1 equal to row 1 minus row 2. So this implies this guy is 0. 0 minus 0 is 0. 2 minus 1 by 3, we will get the 5 over 3. Here is 0, here plus 1 by 3, here you will get it as 1, here you will get it as minus 1 by 3, here you will get the 0, 16 minus 25 by 3 is, you will get it as 28 divided by 3. Next, similarly, I want to make it as, this guy is R2 the same way. R3 also R3 minus R1 because I want to make it. So here R2 is 0 minus 0. Here you will get 1 minus 1 by 3 will get is a 2 by 3. So here you will get 0. Here you will get 1 by 3. Here you will get 0, here you will get minus 1 by 3, here 1, here you will get it as 10 divided by 3. So now what is the maximum negative number is? So this is the guy. So this is, so my x1 is the new. So now I divided the solution column, this one divided by this column. So what is the element by elements means? You will get 28 divided by 5, that is the ratio. You will get it as 20, you will get it as 5. So this is the minimum ratio. So now x1 is the leaving variable, so x1 is the entering variable, R2 is the leaving variable. So you taken as this one is x1 and this guy is, I want to make it as 1. So I want to divide by 3 by 2. So 3 by 2 means 1, you will get it as 0, you will get it as 1 by 2, 0, minus 1 by 2, 3 by 2, then 5. Now I want to, this guy also I want all the column apart from the last element, everything must be 0 only we required. So here we get it as S2 and here is the S1. So first I want to make it as 0th row. zeroth row is R row naught equal to row naught plus 197 divided by 3 or row 3. So row 3 first divided by the 3 by 2. Now, so what will get it as? Here we will get it as 1, here you will get it as 0, here we get it as 0, here you will get 1 by 2, here we get it as 0, here 199 divided by 2, here you get 197 divided by 2, here you get as minus 25. Then x2 coefficient, here also I want to make it 0. So row 2 is row 2 minus 1 by 3 row 3. So you apply the idea 0, here you will get it as 0, here you get 1 minus 1 divided by 2, 0, 1 by 2 minus 1 by 2, the right hand side you will get it as 5. Similarly, row 1 means I want to multiply the minus 5. So row 1 equal to row 1 minus 5 divided by 3 row 3. Okay, so that is third row I want to. So I want to make it as this idea. Here also you will get 0, 0, 0, minus 1 by 2, 1, 1 by 2, minus 5 divided by 2. Here you will get it as 1. Now you clearly look in the 0th row, there is no positive, there is no negative terms. So that means our optimum solution is exists. So from that, x1 equal to 5, x2 equal to 5 and minus z equal to minus 25. This implies z equal to 25. This is our optimal solution. I hope you understand how to apply the Bigham method to solve the linear programming problem. Thank you for watching this video.